Hi, I'm Toby and welcome to another episode of The Joy of Mathematics. If you're an old viewer, then you might know that I like including my cats in these videos, and if you're new, then let me introduce you to Henry, Skittles and Ketchup. In this video I have a special announcement, which is that I have just released some shirts for my channel, and this is the first design. It is a Klein bottle kitty. This is one that Ketchup modelled for, and if you want to get one I'll leave a link in the description, and it's a way that you can support my channel and I really appreciate it. Ketchup appreciates it too, having his face out there. There are multiple colours including black, grey and red. To celebrate the shirts, this video is going to be dedicated to math for cats, so invite your cat over to watch this video with you and you might learn a thing or two. We're going to learn how to select the perfect cat for you, how cats can pick the best spot in which to sleep, and also look at some of the divine geometry of a sleeping cat. Ketchup himself was recently adopted by my family from a rescue shelter. But how did we know that he was going to be the best cat for us? There were a lot of options to choose from and we had looked for a little while. It can be hard to know that you're making the best choice. But if we put our thinking caps on, we might actually be able to use a little bit of math to ensure the best chance of finding the best cat. If we say that every cat we look at will be taken by someone else if we don't take it, then that means we can't go back to a previous option, and we should only turn a cat down if we think the best is still to come. But that could lead to disappointment because we don't know what's out there and we don't know if the best has already passed us by. We need to strike a balance between looking at options to gather data and taking whatever meets the standards that we've established. I'm going to treat this as an optimum stopping problem, which is a common class of problems in maths and computer science which balance looking and leaping. Maths allows us to work out this balance exactly, and it works out to be 37%. If you want to maximize your odds at finding the best option, you should look at 37% of the options, just looking, not committing to anything, just calibrating and gathering data. And then after 37% of the options, you should take the next one, which is better than all the ones you've seen so far. So let's have a little look at this. If we had just one option to choose from, then of course we should just take it. If we had two options, then the best we can do is a 50% chance of finding the best cat. Either we take the first one and leave the second, or we take the second and leave the first. We can't really do any better than chance. But for three cats, we can do better than chance. If we were to just pick one randomly, we would have a 1/3 or a 33% chance of finding the best cat. But we can do better than that. With the first cat, we have no information. And with the last cat, we have no option. We just have to take it by the time we get there. But with the middle cat, we have a bit of both. So if we decide that the first cat we look at, we're never going to get it. We're just going to use it as a way to gather data about the next two. Then we'll look at the first cat and only accept the second cat if it is better than the first one. If it's not, then we'll leave it and move on and take the third cat. That actually increases our chance of finding the best cat out of the three to 50%, which is better than chance. As you start to look at more and more options, the percentage of the options that you should look through converges to be 37%, which is 1/e, the mathematical number, Euler's number. By some nice symmetry, this method also gives us a 37% chance of finding the best option. We can apply this to time too. So if you want to set aside 6 months to find the perfect cat, or 180 days, then you should relax and just look for the first 66 days, about 2 months, and then after that time period, accept the next cat you see, which is better than all the ones you've seen so far. In reality, people often stop their search actually before it is optimal to do so. And that's because there are a few factors that I haven't considered here, and one of them is the cost to keep looking. In reality, there is a cost of your time to keep going and looking at all these cats to gather data and calibrate, and there's also a bit of an emotional cost to keep saying no to the cats you look at. So I would forgive you for stopping your search a little early. Now we are going to tackle the topic of exploring versus exploiting, and which balance of those two things can lead to the most fulfilling life or the most fulfilling outcome. In terms of our cats and their problems that we're trying to solve, one thing I've noticed is that Ketchup, my little kitten, is constantly exploring and looking for new places to sleep. He hasn't quite figured out where the best places are yet, and he hasn't really found a favourite spot. Skittles seems to do a lot less exploring of new places and more exploiting of a place that she's already decided is pretty good. The explore versus exploit problem crops up many places in our own lives, and one example to illustrate one kind of solution would be to imagine that you're in a casino and there's a whole bunch of slot machines, all with a different probability of giving you a win, of being successful. Now, if you had 100 pulls, so you could use 100 turns on any of the levers, what would you do? So you'd have to balance some sort of exploring at the start to figure out which of the slot machines has good probability of giving you a win, and then trying to exploit those ones that you find are good. It wouldn't make as much sense to just randomly take turns on different machines throughout your 100 pulls, because you haven't exploited any of the good machines. But you also wouldn't want to spend your whole time exploiting just one machine, because it might not have been the best one to use all your turns on. The mathematical solution here does depend a lot on how long you have to spend in the casino, or how long you have to enjoy the returns of whatever it is that you're trying to exploit. You wouldn't want to find a really good new sleeping spot on your last day living at a certain house, and you wouldn't want to find a really good new restaurant the day before you're about to leave town. You want to have some time to be able to exploit what you find. One strategy is to stay with an option as long as it keeps paying off, as long as it keeps giving you wins. But to switch to a different option just because of one bad experience does seem a little bit brash, and it might have just been one bad day. You don't know that it's necessarily a bad option. A better strategy could be to use something in maths which is called the Gittins Index, but for the purpose of this video we're going to refer to it as the Kittens Index. Now, this is a way to mathematically maximize payoffs, and it takes into account that exploring an unknown option can be better than just sticking with a known one. In this model, a good outcome today is worth more than a good outcome tomorrow. For example, if you believe that there's a 1% chance that you might get hit by a car on any given day, then you should value tomorrow's sleeping spot at 99% of the value of today's sleeping spot, because you might never get to have it. So what we should do when considering options is to always take the option with the highest Kittens number, or Gittins number. Now, these numbers themselves are quite difficult to calculate, but what we can do is look up values in a table that someone else has already calculated and apply this table to our own situation. So I have a bit of a table here, and it has the number of wins versus the number of losses. So this is the number of good experiences we've had in a certain sleeping spot, and this is the number of bad experiences we've had. The values in this table are, as they say, discounted by 99%, so that just means what I said before, that a good spot tomorrow is worth 99% of the value of a good spot today. There are a few interesting things to note in this table. For example, here, an option of 0, 0. So that's an option you have absolutely no experience with and no data about. has a value of 0.87, and that's actually higher than a lot of other values around here. It's higher than this option here, which has a win 2 out of 3 times and it has a value of 0.83. So it really does value the idea of an unknown experience because it might actually really pay off. But as you gain more and more data, so you go down this diagonal here, these are all options that are actually 50-50. They have an expected value of 50-50. It's either 1 loss, 1 win, 2 losses, 2 wins, down to 4 losses, 4 wins. If you keep going down this diagonal, you will eventually get to 0.5, which is the real probability there, or the real expected value. But it doesn't converge to 0.5 until you have enough data to really be quite certain that that's really what it is giving you in terms of returns. We can see through these numbers that trying new things increases our chance of finding the best, provided that we do have enough chance to take advantage of it. So if we take it back to my example with my cats, maybe Skittles has found a place to settle down and exploit because maybe she's found one with the value of 0.95, ones with 4 wins and 0 losses. And that's higher than the completely unknown option that you have no experience about. So it makes sense for her to pick this option given that she knows about it. However, Ketchup doesn't know about these options yet, and to him all of the new options are worth quite a high value, so he might as well try them all out. Of course, he wouldn't go back to any of these options down here, which have very low values, much lower than the idea of trying somewhere new. And that makes sense because these places here have given a lot of bad experiences. One of the big assumptions that we're making here is that the probabilities are fixed over time. So the probability of a spot being good is not going to change. In the real world, maybe these probabilities are changing a bit, and so in that case it would make a bit more sense to continuously explore the probabilities because they could be going up and down. Our last example of cat math that we're going to talk about today relates to the geometry of a sleeping cat, and it also relates to the Fibonacci or the Fibonacci numbers. Now these are the numbers which I've got up here starting with 1, 1, 2, and you add every number to the number that came before it to get the next one. So 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 2 is 5, 5 plus 3 is 8, and you keep on going like that. Now if you were to take 2 of these numbers and find the ratio between them, so take 8 and divide it by 5, you're going to get a certain value, and as you go further and further along this sequence of numbers, that ratio between each number will get closer to something called the golden ratio, and it's about 1.62. Now this golden ratio doesn't just crop up as the ratio between Fibonacci numbers, but it also is a ratio that comes up a lot in geometry, and some say that to have the golden ratio in a shape makes that shape very aesthetically pleasing. I'll draw a golden rectangle as an example of one of these shapes for you. So in this rectangle, and I'm not using a ruler so please forgive me, the ratio between the length of the sides, between this side and this side, is about 1.6, or is the golden ratio. Now we could keep splitting this rectangle up, so we could break this off into a square here, and then we'd have another golden rectangle here, do the same thing down here, and just keep going like that, getting more and more golden rectangles. Now this set of golden rectangles can make a spiral that crops up anywhere from like a seashell, just different bits of geometry, or you could even go on a bit of a stretch and say that you could find a sleeping cat within this shape. A long tail there. Looks a little bit like a cat. I've definitely seen my cat sleeping in a position like this a few times, and I don't know if they do that to look as aesthetically pleasing as possible or if it's just a coincidence. But thank you for watching this episode of The Joy of Mathematics. I hope that you or your cat maybe learned a thing or two, and I hope that you have an absolutely mathematical day.